Well, good morning. How are all of you today? Enjoying the conference?
Yeah, we are.
Great. I am Homer Hummel. I'm an employee of Computer Sciences Corporation. Well, that doesn't show on here. Come on in. Have a seat. CSC has a software support contract with JPL. And that's how I'm associated with JPL. This presentation has been approved by JPL Document Control for limited release to U.S. citizens as well as foreign nationals. I'll say that up front. I work at Jet Propulsion Laboratory, operated by California Institute of Technology. And there's my email address. You may want to write that down if you have any questions. To send me email. The slides, I've given the slides to the OSCON committee. They haven't posted them yet on the website. They told me they will be doing that this evening. So let's get right into the presentation. Here's the overview. First talk about Unix load gen. That's what I'm calling my framework for load testing using Perl. Cover a load test configuration and use of RSA authentication in Unix fork. Typical run scenario, directory structure, file formats, and I'll actually get into some snippets at least of the Perl scripts that I use. In a sentence, this is a definition of Unix load gen. General framework for load testing and application service. It's written in Perl. Uses fork feature of Unix. RSA authentication feature of SSH. It will be distributed on a website after the software gets reviewed by JPL and approved for release. I don't know exactly what website it will be on. Most likely the openchannelfoundation.org website. But again, send me an email if you're interested, and I'll tell you where that will be. I call it Unix load gen. For the rest of the presentation, I'll use the word load gen. I would have used load gen throughout. However, Microsoft has a product called load gen they use for load testing Exchange servers. And there's a company in Denmark that also has a product called load gen. So officially, I'm calling it Unix load gen, but in this presentation, I'll be using just the word load gen. And this will also be the last slide that I use, the OSCON orange. I do like their dark blue, so I'll be using that in the rest of the presentation, the logos. Here's a diagram of a typical load test configuration. See this type of configuration in commercial products as well. See there's a control workstation, a set of generators, talking with the test server. The idea here is that each generator will run multiple virtual users. And so that the totality can run into hundreds of virtual users. So the question is, well, how many generators? Well, how many can you afford? This is what that boils down to. And I know at JPL we're getting into blades and virtual machines, so that's a possibility. You can certainly use commodity PCs, cheap $500 PCs. Again, they don't have to have, if you're going to have 30 of these, if you lose a couple, no problem, you can still run. So again, you can use commodity PCs for the generators. I use the term generator here throughout this. Really, it's a test client. The processes that run on the generator test clients to the test server. And the idea behind at least the load gen scripts that I've written is that you'll gather statistics about measuring the transaction times, client-server transaction times, to get a server response as opposed to just putting a load on the server. RSA authentication, come on in, have a seat. RSA authentication, there's a certain setup to be done on the control workstation in SSH. I show here a local account called tester. This could be your own account. But what needs to be done is generate a public key pair on the control workstation. It's your private and public key. And then install the public key, that same public key, on each of the generators. So this is a manual step. takes a little bit of time to do that, but you gain from that so that you can run scripts without having to type in an interactive password. Also, not shown here, but you have to do configure SSH on both the control workstation and the generators to say RSA authentication, yes. That part's fairly simple. Since there is a lot of work here in setting this up, you might want to consider setting up an alternate control workstation. Again, on this, you generate a public key pair again and distribute the public key, which you see here in blue. This is the only one where I use ASCII color coding for those of you who are chromatically challenged. So you, again, distribute the public key and then you have an alternate control workstation as a backup. Now, I'm not going to address backup and recovery in this presentation, but I'll just mention that you of course, do want to have a backup of your scripts and data files that are on the control workstation. You may want to do this with a network drive or AFS. Have some golden copy. In fact, maybe a better solution might be another server with a subversion repository. And not only you get backup, but you get version control and history as well. Any questions about this? If you have any questions, just raise your hand or shout, "Hey, Homer, got a question?" Okay. Unix fork. There's a typical generator, and I've got a Perl script that forks, in this case, Y instances of a load script. And so each of these load scripts are child processes of start and.pl. And they each talk logically to the test server. Again, so going over one network port. So this is one thing to keep in mind with load testing is that, particularly for tests that have throughput issues, is that the more instances of the load script that you put on the generator, the more impact it's going to be, the more loading itself because of the extra processes, but also all of the communication with the test server goes through one network port. So there's a little bit of loading there. You're talking about client-server transaction times, you want to keep that to a minimum. Okay, this is a typical load gen run scenario. I'll go through this step by step, but you'll see that there's a control workstation at the top. There's 4 separate processes that you go through in order. And at the bottom of the control workstation, you'll see a control file that's used. The general format is the generator host name followed by a command string. I'll get into that in a little more detail later in the presentation. So the first step is to edit scripts and data, and also the control file if that needs editing. Next, you go to a script called pushfiles.pl. Again, here we're just using the generator host name from the control file. Pushes scripts out to the first generator. And then it steps down through the control file to the next generator, etc., through all the generators down until you get to the last one. And then all the scripts and data files are pushed to the generators. Next, we want to start the load test itself using the loadgen.pl command. Here again, stepping through the control file, starting up Y instances on each of the generators. Starts up generator 2 and all the other generators. And by the way, between starting up each generator, there's an option on the command line for a delay between starting up each generator so you can have a ramp up of load to the server. And so then all of the load scripts are running, and while this is running, and cooking as I call it, it runs till the number of iterations that you specified for the load test have been satisfied, in which case the child process on the generator finish, and then the signal goes back to the load gen on the control workstation, and then it automatically then, when they're all finished, starts retrieving raw results. And again, going back, yes?
Could you create a set point such that the test can quit once they reach a certain latency?
Yes. I haven't implemented that, but that certainly could be done. I do have a script, a separate script that you run in a separate terminal window called stop.pl, which you can stop a test prematurely. In fact, sometimes I've been asked by the directory service to run a test. It says let it run for several days. So I just put in 10 billion iterations, and then I stop it when they tell me to stop it. So that's the approach I use now. Again, retrieving raw results from all the generators one at a time until they've all been retrieved. And once they've all been retrieved into the control workstation, the next thing you want to do is run a script called process results. And that produces a test summary report, and I'll show you an example of that later in the presentation. Okay, and here again is a composite of the typical ones. Questions? No? Okay. Here's the LoadGen directory structure. The indentation on this slide denotes a subdirectory. And you see here at the top level the home directory of the user account tester. And under that directory is called control, data, raw results, scripts. The control directory and the results directory are only really needed on the control workstation. And you'll see subdirectories which have to be, which are not in the distribution, but which have to be entered here for test type. And generally I use the name of the load script for that test type. And that simply makes for a smaller size of data that's associated with that test type. So when you push data, you don't have to push the whole data tree for all the different types of scripts you'll be using. Just the one you're interested in. That's basically why that's done. Okay. Another thing we like to do in load testing, quite often you want to have unique input data lists. As you can see, I have an example here that I've done. I have a Perl script that just creates these in a few seconds. Again, the first file, names 000, its contents are test user 1 through test user 50. Second file, test user 51 through 100, as you can see. Each of these files have unique ranges of test users. Now, what you want to do for the generators is have a list of names parameters. And as you can see, again, the path of the names file is relative to the home directory of the tester account. So there's this minus names parameter, and again, as each have a special script that when it starts up, in this case, 5 instances of a load script, it starts up each instance with its own unique names parameter. As you can see from the names of those files, they're going to give you unique ranges of test users in each of the load script instances. And then, of course, for each generator, you need a different list of names parameters file. And so the first one there, this first one on the list, you'll see I've already expanded it here. So sort of a pop quiz, this next one, list 01, what do you think will be the contents of this second file? Take a stab at that. 5 to 9. Right, exactly. Same as up here, only now the names are going to start name 005 through 9. Then the next one, 10 through 14, etc. Until you get to the last one, whatever that is to be the last one. In this case, it doesn't use up all 199 files, but it uses up as many as you need to get those unique parameters. Okay, questions? Now for the control file, we'll look at it again in general. There's the generator host name, followed by a command string. Here's an example of a control file that I use for Jabber. And here's the case where I'm using the LoadGen framework to just run the Jabber simulator on multiple generator machines. So I have one big long command string for that. And again, I have other, for this particular test, I have others, another utility script that takes a generic Java configuration file, pig.xml, and produces unique user ranges in that XML file, and then pushes those files out to the Java simulator user. So here's an example of the general format of the control file. A more specific format would be one that starts up Y instances of the command string. Okay, so I've got a special script to do that. I have an example here, but even more interesting is control file with Y instances with unique parameters. This one I use quite often. As you see, again, it has the same general format. It starts out with a generator hostname, followed by a Perl script that says start in upl.pl, the UPL standing for unique parameter list. And so it's going to start up Y instances of this command string out here, and then here's our list of names parameters, which has a unique names file to give to each of the this command string to spawn, etc. for all of the generators. And here's an example. Again, these paths here for these scripts are relative to the home directory. In this case, we're going to start 10 instances of the load script. We're using this names parameters list that has 10 entries in it. And we'll start up this script, load.editor_linux.pl. Another thing to notice from this one is that the last one has a different script that's running here. In fact, in this test, I don't show it here, but the first 5 are using this mod adder script, which is a modifying attributes in an LDAP directory, which are writes, and the last 5 get entry, which are reads. So I'm doing both reads and writes in an LDAP directory in this test. Okay, script's standard format for our raw results file. I've got a special format for the name that begins with some fields that are separated by a tilde character, test run ID, the server name, the generator, and a log followed by a process ID to get a unique file name. And the contents are just the start and stop time separated by a comma. Again, one line for each iteration of the load script transaction. And here's an example. Pretty straightforward. It's what you get out of a timestamp using time high-res. Okay. Here's an example of the summary report file. So the name of the server, type of test, test run ID, begin and end time of the test and its duration, and then some statistics in seconds, the minimum, these are for the transaction time, the minimum, average, maximum, standard deviation. In this case, the average transaction time was 2.894 seconds. And then a list of the test clients or the generators and the number of concurrent users there. Any questions about this report? This text report. One of the things to watch out for, a lot of people want to take the total number of transactions here, 5,000, and multiply times the average and try to see if it matches the duration of the test. The problem with that is that you've got concurrency going on, so you can't, that doesn't work. A lot of people make that mistake. Okay, now let's look at some snippets of some of the main files involved. Push files. Again, got a couple of lines here at the top that just trap an interrupt signal, and barely, this initializes and then sets a flag on interrupt. And then that can be used to gracefully exit loops in your script. Second group of lines there, again, processing the control file and just making an array of machine names and an array of command strings. Scripts. And here's the rest of the push file scripts. Notice at the bottom it does a last if that control C flag is set. So that sort of gracefully interrupts. The other if statements are looking at the flags and doing an SCP copy These are the main statements in this script. Push out scripts to the remote machine with SAP. And again, because of the RSA authentication, you don't have to type in a password interactively. And lets this for each loop just proceed through all of the generators. Any questions? Okay. Here's a snippet of the login script. Just want to point out that this fork block is pretty much taken out of the Camel book, page 715. A few things I've added here, and then we'll look at the highlights again. This for each loop, and it accepts an SSH to the generator, followed by the command string. And here's where we put on a test run ID parameter that gets sent then to each of the processes. And at the bottom, I put in a ramp-up delay between starting up the generators, and that's what you see there. Process results. This snippet shows getting all the raw results files, again, for a particular test type. I want to get all of them for just this test type that you ran. And I do ls-1 here to get a list of file names. Got to thinking after I went to the Perl security tutorial, and I got to talking about don't unnecessarily spawn a shell with backticks. But in this case, this doesn't involve user input, so I think it's safe enough that you may want to use like read dir, Perl's function instead. And then the second half down here says out of those files, you want to split the test ID out of the file name and then push that onto a list of raw results files. But you just want to look at files for this test run ID. You may have several tests, and they're all going to have results files in that directory. So you want to pick the ones just for this test run, the process. The rest of this process results file is just rather mundane. You know, it's subtracting start and stop times to get intervals, samples, and doing all the statistics, running track of the minimum, maximum, getting the average of standard deviation, sort of mundane stuff, but it's all commented, and you'll see that in the distribution. Also supplied a couple of load script templates. This is the basic one. There's another one I have for unique parameter lists. But I'll just describe this quickly in three parts. There's a get options, or get up long. It's just host name. It's used for putting the generator host name in the raw results file name. Uses time high res. Again, trapping interrupts, some variable definitions, setting up the output directory for raw results, start and stop times. Here we're getting the options. And again, down here we set up the actual output directory for raw results. And notice I have under test type, and here you'd substitute the actual test type in this command. And then here again, setting up the name of the raw results log file for just this instance. And you'll see this $, the process ID makes that neat. And the remaining part of the template, the main processing loop, and that's a sandwich for, here's where you put your client-server transaction in Perl, right here. Sandwich between the start time and stop time. Again, check to see if you've got an interrupt, so you can exit gracefully, and an optional delay between iterations. And then when all the iterations are finished, or this is stopped prematurely, then you output the raw time results, simply copying this array out to the log file. Any questions about that? I see any problems here? One of the things I've been thinking about is, I thought, well, gee, I didn't want to do a lot of I/O, but it actually might, considering that, operating systems buffer I/O, it might be just as simple to, instead of pushing this onto an array, to just write it directly to a log file. So think about that. Particularly when you get up to thousands of iterations. So you get this huge array, and Perl is a little time consuming when you go to push extra entries onto large arrays. So that's the reason I thought you might want to consider that. So that's a load script template, and now I'll show you an example of an actual load script test using this template and a module directly from cpan.org. And so, again, this is using the template has unique parameter list. I'll show you that later, but here's the first part of it. And slide, and this shows the lines that I've added to the template. Again, a comment, use this authent simple active directory, and I've added a domain parameter. Okay, here's the rest of it. Again, I've added the domain name to the options processing. And in this area, you'll see how I've actually substituted for it. On the template, it says test type here. And here I've added this load active directory to set up the output directory, load 18 minutes. And the main processing loop. But again, you'll see this part's been added to the template that has the unique parameters list. Again, it just reads a line from the names file. And if it reaches the end of file, it goes back to the beginning. And then the rest of them is template, except for this is the part I've added from the. In fact, most of this just comes directly from the documentation right out of CPAN. So you how easy this is. And then there's actually a few more lines at the bottom that don't show it, simply outputting to the outputting start and stop time arrays to the log file. I'll show that right off the end of the screen. But anyway, there's a good example of again, I'll show you quickly what was added to the template. You can see how simple that is. Those are the items that were added to the template. And you've got a load test. Okay, here's the list of some of the utility scripts that I have in the distribution. There's actually some more of these ones I just want to talk about briefly. There's the stop.pl command run on the control workstation. And it sends a parameter to a script called psignal.pl that runs on the generators that actually sends the interrupt signal to each of the instances right in the load script. Check generators.pl, it's a script that I run before I run a load test just to make sure the generator machines are all up and running. Make list, that's a Perl script that makes those names files that have the parameters in it. Again, you can modify that for your own purposes. That's pretty straightforward. Make list of list. That makes the file that has a list of the unique names parameters. Servermon.pl, that's for monitoring server resources. And this one actually monitors on an interval that you specify, like every 30 seconds. It monitors the average CPU load and the number of open TCP connections. Now, I used to use this, but it turns out that most servers now have their own monitoring tools. Unix machines have SAR and lots of tools to give graphics displays. So my suggestion is that you just, for the server, have your SA set up some monitoring. For SAR, the monitoring interval might be set at 5 minutes as a default. You may want to, for the duration of the test, have them lower that monitoring interval down to a minute. Because quite often, sometimes the load tests are short enough that 5 minutes is not enough for sampling of the server resources. And then swingbitch.pl is just a script that I use to use the load-tin framework to start up instances of swingbitch, which is an Oracle load test. Okay, so real-world experience. We also have the ability to integrate load scripts written in other languages. I wrote an authentication server load script, and expect. And used that in the LoadGen framework. And with that, wrote a load test of Kerberos authentication servers. Can also be used as a driver for other simulators. I mentioned earlier the Jabber simulator. So I've used it for that. And of course, here's a list of servers that I've used for LoadGen for already. LDAP directory, Active Directory, POP3, and IMAP4. That was early on before I started using Yemstone for mail servers. and Remedy server, Kerberos, and Jabber servers. Okay, any questions about other experiences I might have had? Yes?
Can the control system also be used as a generator?
Yes, it could be.
Because it seems to me the control doesn't do a whole lot, and once everything's prepped and ready to go, you just run more machine.
Right, it doesn't, yeah. If you're short on machines, yeah, it can certainly be used as a control machine. Again, the general idea is that you want to have as many generator machines as possible because, particularly for throughput tests, where throughput is an issue because you have to go through one network port that can become an issue. But again, you can use some fairly cheap commodity machines for generators. Okay, here's a general comparison with commercial tools. Flexibility, well, I say they're limited, not because maybe the commercial tool hasn't implemented a load test program in a certain way. It's just not available. Whereas with LoadGen, you can write your own. It's open. Scalability, well, for commercial products, yes, but they're going to charge you for more licenses. If you want to, they're licensed by protocol usually. So if you want another protocol, you pay another tens of thousands of dollars, that kind of thing. But with LoadGen, it's openly scalable for no extra cost, except for, of course, the hardware. But again, cheap commodity hardware. Availability, again, some apps are not available on commercial products. With LoadGen, you just write your own. And of course, the ease of use, well, some might see that as somewhat of a disadvantage to LoadGen. Well, you have to write your own, whereas in the commercial tool, usually you can just point and click to generate a load script. But I think all of the other comparison factors here outweigh that, particularly cost, where the commercial project we're talking tens of thousands, and LoadGen open source, CPAN using this Unix LoadGen tool. Okay, here's some relevant references. I have a Unix LoadGen user's guide, which I'll include in the distribution. It goes over the installation and how to actually run LoadGen and use the templates. The distribution will be a tar file, which you untar in the directory and we'll make a subdirectories for you. Have example files and, of course, all the minimum Perl scripts to run LoadGen. And then these others are just SSH to explain the RSA authentication and system programming for Unix, explain Unix fork, additional explanation on that, and the Camel book, Programming Perl. Again, there's thousands of other books. These, I think, are available right out on the bookstand at the Pollock bookstore. Again, there's lots of other books there. There's some acknowledgments. Perl advisors, that's probably a pretty strong word. I've done the design of LoadGen all myself, but just these people are all Perl experts, and they were quite available if I had any questions. And I think that's one of the things that I appreciate about the Perl community is that people are really open about wanting to help you, and if you have any questions about Perl. I'd also like to thank cpan.org, their sponsors and authors, especially Christian Hansen, who wrote the Offend Simple Active Directory script that I used in this example today. I don't want to overlook management, but although sometimes I do, but they were certainly supportive of the work that I did with this LoadGen framework, and particularly when they found out that it really did save money. So, thank you all for coming. Fill out the evaluation form online.